Assalamualaikum and hi, my name is Wan Nurhayatul Rusna binti Rosli, metric number CD20155. Now I'm going to explain a bit about introduction of this computer programming group project. The C++ programming language provides a model of memory and computation that closely match the most of computer. In addition, it provides powerful and flexible mechanism for abstraction that is language construct that allow a programmer to introduce and use new types of object that match the concept of an application. Computer programming is a step-by-step process of designing and developing various set of computer programs to accomplish a specific computing outcome. The process comprises several tasks like analysis, coding, algorithm generation, checking accuracy and resource consumption of algorithm, and etc. The purpose of a computer programming is to find a sequence of instructions that solve specific problem on a computer. As for this project, we have chosen to assist Mega Metal Company to provide production planning. Our group need to develop 3 programs to guide their operator in using conventional machining for selected part in lathe machine, milling machine and drilling machine.
Assalamualaikum warahmatullahi wabarakatuh. My name is Natasha Hani binti Azahar and my metric number is CD20104. I'm going to present about machine specification. For the first machine is lathe machine. The model is TK1060. Capacity swing over bed is 1060 mm. Swing over cross slide is 750 mm. Swing over gap is 1610 mm. Center height is 530 mm. Width of gap is 570 mm. Bed width is 560 mm or 660 mm. Between centers is 2 m, 3 m until 10 m. Headstock is spindle board is diameter is 156 mm. Optional for 230 mm or to change the diameter. Spindle nose is A2 11 optional, A2 or 15 or A2 20. Spindle speeds in RPM is 9 to 600 for 12 steps. Main spindle motor is 20 HP. Feet and threads cross travel is 540 mm. For cross feeds, 0.065 until 0.96 mm. Longitudinal feeds is 0.13 until 1.92 mm. Lead screw diameter is 50 mm. Threading range metric 2 until 30 mm. Pitch is 44 kinds. Threading range in inch 1 until 15 ppi. Module pitch thread is 1 until 15 m. DP pitch thread is 2 until 30 p. Compound rest travel is 300 mm. Tool size is 40 times 40 mm. Rapid motor is 1 over 2 HP. Cross fits is 0.065 until 0.96 mm. Tailstock quill diameter is 140 mm, optional bigger quill diameter. Center taper is MT6. Quill travel is 300 mm. Miscellaneous is coolant pump 1 over 4 HP. Net weight in kgs is 5650 is for 2m, 6100 for 3m, 7450 is for m, 8550 is for 5m, 9650 is for 6m, 10,750 is for 7m, 11,850 for 8m, 12,950 for 9m, and 14,050 is for 10m. Next is for milling machine, model X 6323. Table dimension is 230 or 1,700 70 mm, width and length travel 610 or 350 or 380 mm. So for X, Y, Z and axis, face gear head, or it's called PGH. Head structure is vertical steel head, or it's called VSH. Non-face head. Spindle speed is PGH 80 until 5400 RPM, and for VSH is 80 until 8400 RPM, and for NPH is 60 until 4200 RPM. Spindle rotation angle is 45 degree. Ram travel is 305 mm. Ram rotation is 350 degree. Machine size is 1500 mm times 1530 mm times 2100 mm. And for machine load is 250 kg. And this is the last machine, which is drilling machine. For the model, the model number is 19 kbr. Its brand KM Panchal. Drilling cap in steel is 20 mm. Drilling cap in CI 23 mm. Tapping cap in steel M13. Spindle tapper is MT2. Spindle speed RPM 80, 154, 260, 460, 617, 1100, 1880, 3360. Number of spindle speed is 8. Spindle travel is 125 mm. Time of feed is manual. Diameter of column or length of column is 70.80 mm or 915 mm. Maximum distance between spindle center to column face is 125 mm. Maximum distance between spindle nose to table is 365 mm. And maximum distance between spindle nose to base plate is 630 mm. Upright travel of working table is 250 mm. Size of working table is 270 times 270 mm. Slot size in working table is 7 or 16 inch. Size of base plate is 490 times 310 mm. Size of this slot in base plate is 7 or 16 mm inch. Working surface of base plate is 270 times 235 mm. Electric motor 1 HP or 1440 RPM. V-belt size is A43. Height of machine in kg is 99. Overall dimension of machine height times weight times length is 1000 times 390 times 630.
Hi and Assalamualaikum. My name is Nurul Atika binti Ridwan. My metric number is CD20001. My part for this report is design part and operational analysis. There have 3 design in this report. First, lathe machine design. Second, milling machine design. And lastly, drilling machine design. Now for operational analysis. First, lathe machine. Lathe machine can be used to perform different type of operation. In this project, straight turning, drilling and cutting of operation is enough to produce our product design. Step 1. Set up the lathe machine. To start the operation of the lathe, a suitable lathe machine is chosen as a main machine for us to carry out the lathe process. Make sure all the components of the lathe machine can be functional and all in good condition. Step 2. Select the design. Before using the lathe machine, design of the product should be determined. Marks can be done on the workpiece to make the lathe process easier. For certain case, a center punch can be used to make a small dent on the surface of the workpiece. Step 3. Set up the workpiece. Choose a suitable workpiece before start the lathe process. Step 4. Carry out lead operation. Take safety precautions such as wearing safety glass and ear protection before using the lead machine. Step 5. Clean up the workpiece. After the lead process, we must clean the workpiece. And lastly, step 6. Clean up the workpiece. Second, milling machine. Milling machine can be used to perform different type of operation such as plane milling, face milling, side milling, angular milling, gang milling, and front milling, profile milling, and others. In this project, plane milling and face milling operation is enough to produce our product design. Step 1. Set up the milling machine. To start an operation of milling, a suitable milling machine is chosen as the main machine for us to carry out the drilling process. Make sure all the components of the milling machine can be functional and all in good condition. Step 2. Select the design. We must select the design and to proceed the process. Step 3. Set up the workpiece. Choose a suitable workpiece before starting the milling process. Every milling machine has its limitation on the workpiece. Step 4. Carry out milling operation. Take a safety precaution such as wearing a glass. Step 5. Clean up the workpiece. After the lead process, we must clean the workpiece. Step 6. Clean up the workpiece. After we finish clean up the workpiece, we need to clean up the workpiece using the SOP that we show on the place. Lastly, drilling machine. Drilling machine can be used to perform different type of operations such as core drilling operation, remaining operation, plane drilling operation, boring operation, and others. In this project, a plane drilling operation is enough to produce our product design. Step 1. Set up the drilling machine. To start an operation of drilling, a suitable drilling machine is chosen as the main machine for us to carry out the drilling process. Make sure all the components of the drilling machine can be functional and all in good condition. Step 2. Select the design. We must select the good design to work this project. Step 3. Set up the workpiece. Choose a suitable workpiece before starting the drilling process. Every drilling machine has its limitation on the workpiece. Step 4. Carry out drilling operation. Take safety precaution. Step 5. Clean up the hole. After drilling, some material scrap may still on the workpiece. To remove this scrap, a brush can be used to clean up the workpiece. Step 6. Clean up the workplace. After the lead process, after the milling machine process, we must clean the workplace. That's it from me for part design and operational analysis. Thank you.
Assalamualaikum and hi, my name is Zulfikri bin Zulkafli. My matrix number CD2000088. And now I want to show the flowchart of 3 different types of machines, which is lathe machine, milling machine, and drilling machines. And I will explain it a little bit. So the first one is lathe machines. So first is start, and then we are going to the decision part. They are trying turns to make sure the positions of workpiece. If the decision is no, the process will be error and straightforward to the end session. But if the decision is yes, you must input the X positions and then continue to the decision part of angle cut. If the part have a angle, the decision will be yes, and you must input the angles of your cut. If no angles, just straight to the input the depth of cut. After that, you can insert the distance of cuts, and then the process cuttings will start. Then stop the machine, and the last one will be going to the end session. So for the next flowchart is for milling machines. First is start, and then we continue for the process part machines. This is our product plate with 4 holes. Specific speeds 100 to 2500 rpm. Material size length 80 mm, thickness 30 mm. Cutting speed, here we have a 3 different speed, which is 100 mm per second, 33.33 mm per second, 15.33 mm per second. And then we continue for the process that you must enter the parameter value. After that, we continue to the decision part. Here I have 3 decisions, which is your cutting speed is below or equal to 2, cutting speed below or equal to 6, cutting speed below or equal to 10. If your decision is yes, you will continue for the calculation process here, and we end up to the end session. But if your cutting speed is more than 10, that will become invalid value. So for the last flowchart is for drilling machine. First is starts, and then we are going to the input sessions. Here you can insert the length, width, depth, pitch and diameter values. And then we are going to the decision part. Here I have a 3 decision, which is C. C is a cutting speed. Here I have a 3 decision. C below or equal to 2, C below or equal to 6, and the last one, C is below or equal to 10. If your decision is yes, we will continue to the calculations process and go to the end sessions. But make sure that your value of C is not more than 10, because if your value is more than 10, it will become invalid value.
Next, I'm going to present about complete program codes for 3 types of machine: lathe, milling, and drilling machine. The first one is the lathe machine coding. After we complete the flowchart, we insert all the information and function related to the lathe machine into the C++ programming. And to get the output, we must compile and run the program first. So this is the loop for the output for lathe machine. After we run the result, here we can get machining time, energy consumption, solid waste generated, and estimate productivity per day as the result for lathe machine. The next one is the milling machine coding. We're still using the same step as before. We insert the function to the C++ program and insert the detail as follow to the flowchart, and to get the result, we must compile and run the program. So this is after we run the program. This is the loop for output for milling machine. Here we can get machining time, scrap generated, output per day, material efficiency, and energy utilization. So this is the last one. Last one is coding for the drilling machine. We using the same step as before. We put a function and application followed by the flowchart, and to get the result, we must execute, compile and run the project. Here are the output for the drilling machine. Here we can get the total energy consumption, estimate productivity per day, total operation cost, and energy utilization for the result for drilling machine. That's all from me. Thank you.
Assalamualaikum. My name is Nur Shahira binti Salihin, and my matrix number is CD200031, and I will present for the part calculation. So for the first machine, we have the lathe machine. The input for this program is based on the design selected to run in this lathe machine. From this output, it can be seen that for turning and cutting process, the cutting speed and the fit of the machine is depending on the selection of the material and the undergo process. And over here we can see the output for the program, and we have for the parameter value, the fit rate for the cutting speed, machining time, energy consumption, solid waste generation, and lastly the estimated productivity per day. And this is the formula that we use in this program. V equal to pi times 2 times r times n. So for the feet, we have the u over n, and for the distance, we have x1 minus x, feet rate, n times f. So for the total MRR equal to MRR plus V times FR times D, and for the TP equal to L over FR, and for E equal to total MRR times unit power. And lastly, for the EP, for the estimated productivity equal to TP times A times 60. Next, we have the milling machine. For the milling machine, the input for this program is also based on the design selected to run in this milling machine. From the output, it can be seen that for the speed of machine, the process, and the fit is depending on the selection of the material and the undergo process also. And we can see over here is the output of the program. We have the speed of machine for the parameter value such as length, width, thickness, radius of hole, hole to hole distance, distance hole to edge, and also for the measuring time, scrap generated, output per day, material efficiency, and lastly for the energy utilization. And over here we can see the formula that we use in this program, such as y and h equal to d plus rr, d I, j, k, t, and so on. Lastly, for the third machine, drilling machine, the input for this program is based on the design selected to run in this drilling machine. From the output, it can be seen that for the speed of machine, the process, and the fit of the machine is depending on the selection of the material and the undergo process. And as we can see over here, this is the output for the drilling machine program, and we have the drilling speed of machine, the parameter values same with the previous machine, and at the end we will have the machining time, total energy consumption, estimated productivity per day, total operation cost, energy utilization, and lastly the length, width, drill diameter, and part thickness. And this is the formula that we use to generate the program. For the n equal to 100 over pi times c. For the f, we have n times f. For the t, we have d plus a over f, or mrr, pi times c times f over 4. And it is same with the others. That's all for the calculation part. Thank you.
So in a conclusion, the program created can help the operator to solve their problem to determine the part machining times, total energy consumption, total operation cost, byproduct or solid waste emissions, and estimated productivity per day easily and more accurate. The operator just only need to enter the diameters of objects and the feed rate. So based on this project, we came out to study all of the machine spec, machine parameter, and formula used. We understand to use the formula to calculate the cutting speed, feed rate, cutting time, and cutting power to solve the project. We solve the calculation by understanding the step until it reaches its expected output.
Next is limitations or problem faced. For recommendation, a good time management is needed to keep the project running smoothly. There are solutions to keep a good time management, which are create schedule and start early to avoid missed deadline. Next, group discussion should be done face to face because it is hard for everyone to understand the coding, but due to pandemic, we have to face the new norm. Finally, the coding should be done early to proceed for the next step, which is flowchart and the next chapter.